In this example, we're given a state of plane stress, sigma x, sigma y, tau xy. And what we are asked to do is to determine the components of stress on a plane which is 40-degree rotation from the y-axis as shown there in the figure. What I'm going to do first, before we actually do the calculations for the stress transformation, is I want to construct the Mohr circle just so that we understand what sort of state of stress that we have. In order to draw Mohr's circle, I need two numbers. I need the average value of the normal stresses, so that's sigma x plus sigma y divided by 2. 3,000 positive sigma x, a minus 5,000 for sigma y divided by 2. So that averages minus 1,000 psi. The value of r. R is the square root of sigma x minus sigma y divided by 2, that quantity squared, plus tau xy, quantity squared, so this becomes 3,000 plus 5,000 divided by 2 squared, tau xy 3,000, that quantity squared. So the numerical value for r is 5,000 psi. So that's the information we need to draw a Mohr circle. I'm going to draw it on the axes that's shown here. I know that I want my center of the circle to be here at minus 1,000, and I know that the far extreme on the left side is going to be at 6,000, so let me tick this off. 2, 3, 4, 5, 6. So left edge of my Mohr circle needs to pass through that tick mark there on the left hand side. So that's our Mohr circle. So again, the circle has a center at minus 1,000. The radius of this circle is 5,000. Our current state of stress, or at least on the x-axis, would correspond to a positive 3,000 for sigma x, and for tau xy it would be a minus 3,000. So I need to come up to a position right here. The way I have my picture drawn, tau is positively down, so this gives me the location of the x-axis. So I know that the x-axis is along there. Let me do a better job here than that. So this is x. And so what we're asked to find then is what's the state of stress that's a 40-degree rotation from where it is. So that would be, if this is a 90-degree rotation, it would be just a little bit shy of there. So that's going to be somewhere around here. I'm looking for this value of sigma x and sigma y. The point here being is that we know that a rotation of theta in the real world here corresponds to an 80-degree rotation in Mohr's circle. So that's what we're trying to find. Now I'll actually use the stress transformation equations, where we know that sigma is equal to sigma average plus sigma x minus sigma y divided by 2. Cosine of 40 times 2, that's 80 degrees. Tau xy times sine of 80 degrees. Sigma average we saw was minus 1,000 plus 3,000, that's 5,000 divided by 2, cosine of 80 degrees. And tau xy on that face is a minus, so it's a minus 3,000 sine of 80 degrees. This number for sigma is minus 3260 psi. The value of tau on that face after 40-degree rotation is, according to our stress transformation equations, is minus the quantity sigma x minus sigma y divided by 2, sine of 80 degrees, plus tau xy, cosine of 80. In putting my numbers in, this becomes minus 4,000, sine of 80, minus 3,000 cosine of 80. So that number is minus 4460 psi. So this problem is one of just getting us some practice on using these stress transformation equations. At the same time, I took the opportunity to show us where things are in Mohr circle. Again, since we're rotating 40 degrees in the physical world here, in Mohr circle we need to rotate 80 degrees in the same counterclockwise sense.